Hey guys, Mr. Montgomery again. Today we're starting our brand new unit on Force. So of course, since we're talking about Force, I had to bring up Star Wars, and that is my little background right here. Okay, so after today you're going to be able to explain what Force is and how you can increase or decrease the amount of force being applied. Okay, before we go any further in today's lesson, we have to talk about something called SI units, and all that means is standard units of measure. So the abbreviation SI just means standard units of measure, and it's the most common things that we use, throughout science, such as seconds, meters, Kelvin, kilograms, all those things. Those are called standard units of measure. So let's make sure that we have all of them written down, because there's 7 of them. There's a lot. I'm not going to test you on all of them, but I'm definitely going to test you on like the top 3 or 4. So for S, of course, we know that stands for seconds. We've dealt with that quite a lot. I'm sure you guys have dealt with that a lot during math and in any previous science class. M, it always stands for meters. And notice that it is a lowercase m. Okay, even over here, lowercase m, lowercase s. Because if you were to make it capitalized, it would mean something totally different. For kilograms, we have kg. kg is the proper abbreviation for kilograms. After that, we have amps or amperes, which is the capital A. And I know what you're thinking, but in the formula, V equals IR, we have it as I. Now in that formula, it's an I. But if you're going to use it as a unit of measure, you would then use a capital A. Okay, for the letter K, that stands for Kelvin. This is a different type of temperature. Okay, I'm not going to go into it because it does get a little confusing. I don't want anyone to get confused, especially since that's not our huge focus. After that, we have mole, and the abbreviation for that is just the same word, but they took away the E. Like, they were super lazy about it, right? But all mole stands for is the amount of a substance that is being used. And finally, we have candela, which the abbreviation is CD, and all this means is how bright something is, or as you would find on Google, luminous intensity, which just means how bright an object really is. Because we tend to, if I remember correctly, we tend to measure light also in lumens. So luminous, lumens, and then candela would be the unit of measure. Alright, so anyway, let's get back into force and what exactly it is and how we can identify it. So force is a basic push and pull motion. One or the other, either way you will be applying force. This guy pulling on the rope is applying force. The guy that is pushing on this block is also applying force, just in a different way. I mean, we could, since we already learned about Newton this year, we could even say that, there's action reaction forces going on with this version of force than this one. But we can get to that for a conversation later. But force can also be described by the strength and direction that an object is being acted on. Okay, so if we were to say that this person is applying 10 newtons of force and this other guy is pushing with 20 newtons of force, we could say that he is applying greater force in this direction going right. Because if you're applying force to something, you're trying to make it go in a direction. Even if you're pushing down on a table, the direction you're applying force is downward, and then the table is acting in the opposite direction. Okay, often when force is being applied to an object, there is typically more than one force being applied to that object. For example, in this picture right here, you have this super strong woman lifting this very heavy barbell over her head, which looks like, if I were to guess, with all these plates, it's definitely over 200 pounds, probably more like closer to 300. That's a lot of weight. But in this instance, you have 2 different forces being applied to the object lifted above the woman's head. You have first the woman lifting the object above her head, and then second, you always have gravity acting downward, pushing it back towards the ground. So right there we have two forces. Okay, another example. The person in the picture is applying a pushing force to the block, right? Going towards the right side. But gravity is also acting downward on the block, causing it to be harder to move. So there, right here, we have two different forces acting on this one block in the picture. Oh, and don't forget, guys, if you need the video to slow down, you control it. So pause it whenever you need to. And the easiest way to pause is to hit the space bar. Oh man, I totally forgot that this video is in here. I love this video. I will attach the link for this video in the description. It's really a 20-minute video. It's really cool stuff. It's going to show women in a CrossFit competition doing some seriously heavy lifting with this barbell. And they're doing barbell cleans the entire time, which means that they are bringing this barbell from the ground and in one fluid motion bring it to their shoulders, then extending their legs, bringing it all the way up. And I am not joking when I say this. This takes a lot of muscle, and it takes a lot of body control. This is really difficult to do. So I just kind of explained what she was doing in the video. I'm not going to play it though because you won't be able to hear it or nothing. But if you have someone performing this action, what two forces are taking place in the video? Or if they're doing powerlifting, is it gravity and air resistance? Is it the person pulling the weight up and air resistance? Or is it the person pulling the weight up and gravity? What are the two forces acting on these weights? Well, I'm hoping you picked one and you're playing along with me. And the correct answer is going to be the person pulling up on the weight and gravity acting down the entire time. Those are two forces that are always going to be there during this exercise. Okay, so when multiple forces are acting on an object, we call this a net force. So if there's ever an instance where there is only one force acting on an object, then we're not going to have a net force. You must have two forces acting on an object at the same time, and then you can actually calculate the net force and it'll tell you which force is stronger, if they're going to be canceled out, what direction the object's going in. It gives you a lot of information. So net forces are either increased or decreased based on the strength and direction of the object or of the force. So if this weight is getting pushed down, but you're pulling the weight up, we have two forces, right? And if this weight is stronger than your force pulling it up, then it's eventually going to just hit the ground anyway, and the net force will be greatest with this weight, or with the gravitational pull. If you were to be strong enough to lift this weight up and keep it up, your net force would be the strongest, or your force would be the strongest aspect of the net force, since you would be able to keep it from touching the ground. Okay, so there's actually three different variations or results that net force can have. So the first variation is if you have all the force affecting an object on the same side. So in this picture, right here, we have, let's say that at the top, you have someone pushing the top of this block with 10 newtons of force. And then your friend decides to help you out and starts pushing the bottom with another 10 newtons of force, going in the same direction. And we know it's going in the same direction because we see the arrows pushing in that same direction, right? The picture's telling us this. So when we see this happening, all we do, you ready for this? You add them together. That's it. Whenever you have two forces going in the same direction, being impacted on an object, you simply add them together, and that tells you the total amount of force, or the net force, for that object. So the other variation is when you have opposing forces. So these two forces are going in the opposite direction, and they are, and most importantly, these are not equal forces. So let's say you and a friend are horsing around, and one of you is really strong and pushing the block to the left with 10 newtons of force. The other person is maybe a little weaker, and that's okay, not a big deal, but they're pushing the block going the opposite direction, but with only 8 newtons of force. When you have opposing forces, all you do is subtract the 2. That's it. And the difference that you get, your answer, is the net force. And that will tell you which side the object will go in. Since we have the greatest force on the side with 10 newtons, that is the side that would have 2 newtons of net force left over, so that the direction of this box should be going left. Make sense? Just remember, if the forces are being applied on the same side, you add them. If the forces are opposing each other and they're being applied to different sides, then you have to subtract them. Lastly, probably the easiest one, if you have 0 net force. This is when the exact same amount of force is being applied to opposite sides of an object at the same time. The key of this being, it must be the same amount of force on both sides. If this was a 20 over here instead of a 10, it would not be a 0 net force, because one would be greater than the other. But since they are both 10 on each side, they are going to zero out, because if you subtract 10 from 10, you get 0. We have a 0 net force, and that's it. Pretty straightforward, right? Okay, let's check in. True or false? Net force must have at least 3 forces acting on one object at the same time. What do you think? Okay, well, this one, the answer to this is, it's false. We don't need 3, you just have to have at least 2 different forces acting on one object. Okay, so whenever we talk about any of these net forces, they're going to be under one of 2 categories, either a balanced or unbalanced force. So whenever there is a net force acting on an object and one opposing force is stronger than the other, then we call this an unbalanced force. So like in the picture, we have these opposing forces playing tug of war. And these 2 people over here are going to have a stronger force than this person all by themselves. So since these 2 people will eventually win because they have greater force, we would say that this is an unbalanced force. And unbalanced forces can cause an object to start moving, stop moving, or change direction. Okay, and then we have the other variation, right? We have our balanced forces. This is only when we have a zeroed out net force. So like what we saw a few slides ago where it showed the 2 hands pushing on the block, both with 10 newtons of force. That block isn't moving because they're applying the same amount of force on each side. So we would say that the forces are balanced. So if forces are balanced, they do not make an object change motion, move, or change direction ever. And this is going to be our last check-in for the lesson, guys. What should be the end result of any balanced force? Is it the net force is 0? One side will win by at least 1 newton, or one side will lose by 0.5 newtons? And I know we already know the answer to this. It's going to be the top one. The net force must be 0 if they are balanced, because there's no winning side, right? Now, in class, I did play this really funny video of kids doing goofy stuff, and it shows really clearly balanced and unbalanced things. Just remember, if you're able to stay still on top of something, you're balanced. The forces are balanced. Gravity's pushing down, and whatever you're standing on is pushing up, and you won't move, and you'll be perfectly balanced and not get hurt. But if you move a little bit, and you lose your balance, and gravity wins, and you fall to the ground, you are then unbalanced until you make contact with the ground. And that was basically it. But if you want to look this up, it's at least a funny watch. But I hope that this was helpful for you guys. I hope that it may have cleared things up. Or if you missed that lesson, I hope that this helped you catch up and you're not confused. But if there are any questions, please just let me know, whether email me or ask me in class, and I will do my best to make sure everything is as clear as possible. But that's it for today, guys, and hope you have a great day, and I'll see you next time.